Welcome back to another explainer. If you're a focused learner looking to understand the absolute bleeding edge of theoretical physics, you are in exactly the right place today. We're unpacking a really radical theoretical framework that basically redefines the very fabric of our reality. And specifically, we're going to talk about how this theory can be shown in the analog black hole experiments going on right now in terrestrial fluid dynamics labs all over the world. It is fascinating stuff. Okay, let's dive right into this. I actually want you to completely flip your understanding of gravity for a second. For centuries, we've all been taught to imagine gravity as this invisible string, right? Just pulling objects together. But what if we've had it completely backwards this whole time? What if gravity isn't a pulling force at all, but rather an omnidirectional pressure pushing inward from the vacuum of space? I know, it's a massive paradigm shift. So to wrap our heads around this, here's our roadmap for today. We'll start with the liquid universe, move into fractal pressure cosmology. Then we'll check out the zero point 0.4 Hawking exhaust. After that, we bridge over to analog black holes, look at some fluid dynamics in the lab, and finally, wrap up with a new reality. Let's get started. Section 1. The liquid universe. Space as a superfluid vacuum. Right off the bat, we're challenging the age-old assumption that the vacuum of space is just this empty, frictionless void. And this brilliantly illustrates the core difference between the standard model of physics and the liquid universe theory. The standard model, it gives us empty space, pulling gravity, 10 neat little dimensions, and fundamental vibrating strings. But the liquid universe model argues that space is actually a high-viscosity, superfluid substrate. So in this model, gravity is a push, not a pull. Mass simply acts as a displacement point, kind of like a low-pressure sink, that the highly pressurized fluid of the universe just rushes in to fill. The source material gives us this absolutely fantastic analogy, stating, we're the froth and bubbles in a glass of beer, the cavitational wakes of the medium flowing. Just really think about that for a second. In this fluid model, the things we casually call fundamental strings or particles, they aren't tiny rubber bands at all. They're simply the bubbles. They're hydrodynamic cavitation wakes left behind by energy tunneling through the thick fluid of space. It is literally exactly like the turbulent trail left behind by a spinning boat propeller in water. Moving along to Section 2, Fractal Pressure Cosmology, Navigating the 9.6D Space-Time. So the big question is, how do we mathematically map a universe made of thick, pushing liquid? Well, that brings us to fractal pressure cosmology. Essentially, it's a fluid dynamic correction to standard cosmology. Standard string theories usually rely on these really rigid, neat 10 dimensions. But this framework argues that because dimensions actually overlap and share information at their seams, they compress. They squish together into a fractional Hausdorff dimension of roughly 9.6. And that compression creates an omnidirectional thermodynamic pressure, which is exactly what we perceive as gravity. Now, when you compress standard 10-dimensional math through these fluid, overlapping seams down to 9.6 active dimensions, you're left with a 0.4-dimensional gap. And guys, this fractional gap is absolutely critical to making the mechanics of a liquid universe actually work. Let's move to and see how this builds in Section 3, the 0.4 Hawking exhaust, the breath of the universe. We really need to understand exactly what happens to that leftover 0.4-dimensional gap. The dynamic omnipush equation gives us a massive clue, with a reciprocal term at the very end. Think about it. In a high-pressure fluid universe, if energy is constantly pushing inward from all sides, it has to eventually have a way to push out, right? Otherwise, the universe would instantly crush itself into nothingness. This equation demonstrates that the 0.4 gap acts as a reciprocal exit flow. It is literally the exhaust valve of the cosmos. And here's where it gets crazy. When the source calculates the pressure exhaust venting through that exact 0.4 gap, we get this highly specific number, 1121.246. What is so incredible about that is that this number perfectly mirrors the thermal signature of Hawking radiation leaking out of a black hole. In this theory, a black hole is basically just a butcher's sink, a thermodynamic drain, and Hawking radiation, that's just the universe taking a breath, off-gassing its excess pressure through that 0.4-dimensional gap. Section 4. Analog black holes, bridging theory to reality. Okay, this is where we go from theoretical mathematics straight into physical, observable reality. Mainstream physics might still be a little hesitant to formally declare that space-time is a literal fluid, but as this quote points out, the most successful way scientists are studying the Hawking effect today is by using analog fluid systems. Physicists are terrified to admit space is a liquid, yet they're currently using literal fluids in the lab to successfully recreate the exact kinematics of astrophysical black holes. It proves that treating space as a fluid is way more than just a thought experiment. So scientists are utilizing 4 main analog gravity systems right now to do this. We've got water waves in a flowing channel, Bose-Einstein condensates, light politons in a microcavity fluid, and optical pulses in a fiber. What do all of these have in common? Every single one relies on interactions within a flowing, moving medium. They are literally testing the liquid universe concept on a microscopic scale. To really grasp how these lab tests reflect the cosmos, consider how an analog event horizon is actually built. Step 1, you create a flowing medium. Step 2, you accelerate that flow from subsonic to supersonic, which creates a transonic boundary. Step 3, you send a fluctuation wave against the flow. Because the medium is moving way faster than the wave can travel, the wave just gets trapped right at that boundary. And boom, that boundary acts exactly like a cosmic event horizon, shedding measurable analog Hawking radiation. Now, what's really interesting about this next part is Section 5, Fluid Dynamics in the Lab, Visualizing the Horizon. Let's look at experiments using Bose-Einstein condensates, which are basically super-cooled fluids. Scientists use a laser sweep here to create a sink of atoms. That drops the pressure and creates a supersonic region. By doing this, they literally generate an analog black hole horizon right there on the lab bench, and they successfully produce and measure Hawking radiation pairs. It's terrestrial fluid dynamics perfectly mimicking the absolute deepest mysteries of deep space. And it doesn't stop there. In setups using optical fibers, scientists fire a pump pulse through the fiber to create a moving medium. When counterpropagating and co-propagating waves hit this pulse, it creates analogous white hole and black hole horizons. And these horizons actually generate negative frequency Hawking partners. Again, the physics of a black hole are being perfectly replicated by waves moving through a dense flowing medium, which is exactly what the liquid universe theory predicts for the cosmos. Section 6, a new reality. We are the water. It's time to bring the microscopic fluid dynamics of the lab bench all the way back to the macroscopic scale of our entire universe. The crucial takeaway here is this. The fractal pressure framework argues that these analog fluid experiments aren't just clever metaphors. They don't just kind of look like black holes. They perfectly mimic black hole kinematics for one simple reason. Space-time itself acts exactly like these higher-pressure viscous fluids. The lab bench is just a miniature version of the entire cosmic architecture. Which leaves us with a pretty profound shift in perspective. The source material captures this beautifully. If the universe is a liquid and we are the ants, are we trying to build a boat, or are we learning how to become the water? Think about it. If we truly recognize this 9.6-dimensional liquid universe, it completely redefines our technological potential. Instead of trying to fight a pulling gravity with brute force combustion, we could actually learn to surf the pushing wave of the vacuum. So I want to leave you with this final, lingering question to chew on. Are we just measuring the froth on a cosmic glass of beer, completely ignoring the liquid doing all the actual work? Next time you look up at the night sky, do not picture an empty, pulling void. Picture a dense, dynamic, pushing ocean, and realize that we are just the bubbles caught in its wake. Thank you so much for joining me on this explainer. Keep your focus sharp, and I'll catch you in the next one.